We're going to learn about indices and sets. Okay, just a few things you should know before we start learning the laws of indices. If I had something written, now this you can also call it a to the power of n. Alright, a to the power of n. Okay, is actually a times a times a times a. Okay, n times. Alright, so if you had a to the power of 5, okay, what you actually have is a times a times a times a times a 5 times. Alright, I would say this is something you should know before we start on indices. And if you had anything to the power of 1, a to the power of 1, alright, a to the power of 1 is a itself. Okay, if you had x to the power of 1 is x itself. Alright, of course if it's to the power of 1, all you have to do, okay, really is to write it as a or x. In this case a or x. It is understood that a is a to the power of 1 and x is x to the power of 1. Let's go on to the next page. Okay, so some people actually find this interesting. A to the power of 0 is actually equals to 1. Okay, that establishes the fact that anything to the power of 0 is 1, no matter how complicated the number is. A quarter to the power of 0 is also equals to 1. Alright, 2/3 to the power of 0 is also equals to 1. Okay, 0.666 to the power of 0 is also equals to 1. Alright, so in general, a to the power of 0 is equals to 1. Now, okay, now if you have a situation like that, a to the power of minus n, where the index is actually a negative sign, in this case you can see it's to the power of minus n here, right? So what you can do is flip it over and write it as 1 over a to the power of n. Alright, this is something that you should remember. Okay, so let me just box it up here. Alright, so let me give you another scenario. Let's say if you have 1 over a to the power of minus n. Okay, you can represent this as 1 over a to the power of n. Now, because this essentially means 1 divided by 1 over a to the power of n equals to 1 times a to the power of n. You flip it over when you change signs, and then you get a to the power of n. Alright, so basically this is our little introduction to indices. I'm wondering whether we can go to the next page. Let's go to the next page. I'll probably introduce the three basic rules of indices that we have. Okay, right, so there you go. So let me just write it. The three basic rules of indices that you should know. Alright, so if you had x to the power m times x to the power of n, let me just erase this because it might cause a little bit of confusion. Let's call it y instead. What do you say? Okay, that's y to the power m times y to the power n. Okay, what you get is y to the power m plus n. Okay, let me give you an example here. Okay, 5 to the power 3 times 5 to the power 8. Okay, is actually 5 to the power 3 plus 8, which is 5 to the power of 11. Now, if you think about it, 5 to the power 3 times 5 to the power 8 is actually equals to 5 times 5 times 5. Alright, 3 times and then times 5 times 5 times 5 times 5 times 5 times 5 times 5. Let's see, how many times are there here? 1, 2, 3, 4, 5, 6, 7, and then times 5 again. That's what you're doing actually, and that's how you get 5 to the power 11. Now this law allows you to simplify this process by just adding the indexes, 3 plus 8 in this case. Okay, let me give you another example. Let's scroll down to the second page. My handwriting is a little big. If you have got 4 to the power 3 times 4 to the power 8, because they are of the same base, now you can only do it if they are of the same base. Bear this in mind. 4 to the power 3 plus 8, which is 4 to the power 11. Alright. Okay, now let's go on to the second rule. Okay, if you have z to the power m divided by z to the power n, you really can write it like that as well. It really makes no difference. Z to the power m over z to the power m over z to the power n. Okay, eventually when you do work it out, alright, you can write it as z to the power m minus n. Okay, example, say 5 to the power 3 divided by 5 to the power 1. Okay, you can write it as 5 to the power 3 minus 1 is actually equals to 5 squared equals to 25. Alright, now let me do it another way so that you might actually understand. 5 to the power 3 can be written as 5 times 5 times 5 over 5. And what you can do, according to the laws of algebra, you can actually cancel this one out because they are similar factors, and then you get 5 times 5, which is actually equals to 25. Alright, so in a nutshell, for this law, if you have the same base, okay, and you divide one indices by the other, okay, you can actually just deduct the index. In this case, 3 minus 1. Okay, the generic formula is z to the power m minus n. Okay, let's move on. Let's go on to the third and last formula. Okay, if you have a to the power m bracket n, okay, you can actually expand this to be a m n. Well, this actually means a to the power of m times n. You can just multiply it. Alright, you can essentially just multiply m and n to get m times n. Now it means the same thing, it's actually understood. Okay, example 2 to the power of 3 bracket to the power of 5, 2 to the power of 15. That's your answer. Okay, 3 to the power of 3 bracket 2 equals 3 to the power of 6. 2 times 3. Alright, so this spells the end of introduction to indices. I believe that with this you'll be able to do a lot more on your own. Okay, I will be giving you some examples in due course. Stay tuned.